Hey, NAMI students, Mr. Yance again. Hey, I just want to go over where we kind of, or start in where we kind of left off the other day with just kind of introducing the brain and the different parts of the brain. I told you the other day that we're going to kind of divide this chapter into two parts because it's so big, and I mainly just want to go over what are the six parts of the brain and how what do they do? So we're going to go over the five of the six in this part of notes and take a test. And then I got the cerebrum, which is the largest part of the brain. We'll kind of save for more extensive notes later. So this is what I kind of finished off with, this blue and white big trunk of the tree here. That would be your 100 billion neurons. That's a neuron. And then we have 900 billion of these tree branches called neuroglia. And that's why I told you the other day that you're never going to fill up your brain. We have so many different connective points. It's unfathomable how many different ways we can connect our brain and remember information. So we are definitely going to be lifelong learners, and you're never going to fill up the brain with information. So here's the six parts of the brain. The cerebrum is, as you can see with the arrow here, is by far the largest part of the brain. That's what I'm going to do a little more extensive notes on later. The cerebellum is right below here, the second largest, second by a long way. Okay. And then the brainstem is the medulla, the pons, the midbrain, and diencephalon. That's really what I'll focus on, is these 5, 2 through 6. I'll say a little bit about the cerebrum today, but we'll get more into its functions later. So I'm mainly kind of going over the structure of the brain. We'll dissect the brain next week. You'll see all these parts hands-on, and that's basically kind of what I want to do with this first part of notes, and then we'll go in more in detail on the functions down the road, okay? So the cerebrum is really the wrinkly, not a real good scientific word. You can see from this picture, part of the brain where you have your higher mental function, your problem solving, your emotions, your motor skills, your sensory skills, majority of things we do on a daily basis, all right? The cerebellum is more dealing with quality of life, balance, coordination. It's located in the back of the brain. It's one of those deals where if you injure it, you wouldn't die from it, but you would not have the quality of life that you have for the most part. So really super important. And again, I'll go into more detail in a little bit about some of this stuff. All right. The brain stem, bottom line, that's your survival. You cannot damage that. It's tucked deep in the brain. It's well protected. And the reason for that is because it does all your autonomic things, your respiration, your heartbeat, the things that you don't have to physically think about. It just does it, okay, automatically. And that's why sometimes someone may be a vegetative brain dead patient, because their cerebrum may be gone and they may not be consciously there, but their heart can keep beating, their body can keep functioning because of the brain stem. Okay, and that's why we can harvest organs and do organ transplants and things like that. You can see from this picture the brain's pretty complex, and this is what my lab's going to be about. We'll dissect. We'll find these parts. We'll have a quiz over it, a lab quiz. So you'll get to know all these things I have on this picture as we get there. I'm not going to show you the videos today. I've been having some issues with my videos coming up here. This is actually my second try through notes today. I had it almost done, and I tried to hit these videos, and for whatever reason, my computer is just not wanting to do what I wanted to do. So I'm going to skip them. They're very good. I really like them. I may the traditional students I'll probably show you in class. Virtual students, I'll put it on eventually, and you can look at it as well. But let's start with some cerebrum structure. So kind of want to do that today. So kind of fill in your note packet as we kind of go here. The corpus callosum is a thick cable, and basically your brain has a right and a left hemisphere, and it has a deep divide in the middle called the longitudinal fissure, and there's a 250 million nerve fiber connector. You can see it here right in the middle, right here. Okay. That's called the corpus callosum. And it basically connects your left brain with your right brain. And we'll do a little activity with this later where you'll see if you're right brain, left brain, totally different functionings of the cerebrum. But this connects them so we can go back and forth between them really fast, and you don't even know you do it. This video is kind of cool, and like I say, you can watch it sometime. But it is of a person that has a severed corpus callosum, and it's like having two brains in one. Okay, so maybe it's really a good video. I'm going to try it. I hope it doesn't mess up this time. So we'll try it and we'll see how it goes. You may get a little echo, but awesome video. Okay, so let's see if I can get the cue up here. Yeah, probably not. See, I've been having issues with that, and my internet sucks here at home. So watch that sometime, and it's really good. Okay. You can see it here. This is actually a brain that you'll dissect. This is actually one I dissected, and you can see this corpus callosum. Doesn't look like much, but it keeps my right and left hemispheres communicating. You can see a better picture of it here. Okay. Then we have another good video we'll watch too. Then we have some wrinkles in the brain. The wrinkles are called gyrus. The shallow grooves are called sulcus. You'll see that when you dissect your brain. And the fissures are deep grooves, okay? So here's the difference. Fissures are deep grooves, sulcus are shallow grooves. They're both grooves. And we are just now getting to know the outside surface of the brain and what it does. We have no idea what goes on in these deep crevices. I'm sure there's brain activity down there. I'm sure there's things that are valuable to how we function, but we just don't have a clue what that does. Someday, maybe. Okay, so they all have significance. Okay, fissures kind of separate our brain into different lobes. So when we study the brain, we like to say, okay, here's what the occipital lobe does. This is what the parietal lobe does. As you can see from this picture, there are actually some landmarks. Again, when we dissect the brain, this will come more into life, and you have a collar sheet that has some of that on it too. And basically, I'll just kind of go over them real quick, and this will help you. I'm going to try something a little different this year. I'm kind of going to go over this a little bit more. I used to just send my students over, and we dissected first, and then I came back and said, okay, this is what you saw. This is what you looked at. I think it's going to be much easier if I go through all these things with you here. And then you can have a reference point, and then when you actually do your dissection, you'll be like, oh yeah, I know what the transverse fissure is. I know what the longitudinal fissure is. Okay, we'll see. I think it'll work out better. I'm trying some new things. Okay, so transverse fissure separates the cerebrum from the cerebellum. Pretty simple. You have to be really careful when you dissect your brain. Sometimes that breaks off. It's a very delicate area, but you can see it's a deep groove. It's a fissure, and here's my cerebrum. And here's my cerebellum. That's just divides those two from one another. All right. The lateral fissure is a little more difficult to see, but it separates the temporal, this one down here, from your frontal and your parietal. Okay. So it's this groove right here. Okay. And then you have the longitudinal, which is the deepest groove of the cerebrum. It divides it into right and left. And you have the central sulcus that goes across the other way. So these are all just grooves, shallow grooves, deep grooves. And that's what I want you to do when you dissect your brain next week. The first thing I want you to do is look at the overall thing before you cut anything and find these fissures. Find the sulcus, find the gyrus, find the transverse, the longitudinal, the central sulcus, because it does divide the brain up in not only different parts, but it kind of helps us explain this does this thing, this does this function. They're landmarks, okay? That's all they are, all right? And then I'll kind of finish up notes, not a